In this video, I'm going to walk you through the mechanics of k-means clustering. I left some links here at the top of the script that could allow you to go and investigate a little bit more the intuition and the idea behind k-means clustering. The basic idea, stated simply, would be that you want to group rows together that are more similar and keep them separate from rows that are less similar. And so this is a mathematical way to run through each row and to find groups that are more similar across different rows. So we'll see how some of that works, but if you would like to understand more about the details of this k-means clustering, you can look through some of these links. The data set we're going to use is a data set we used previously, or a data set like this. This is company information, so assets, growth, things like that that are from a particular year for that company, and we have multiple years for each company. And then I've added on some location information, so the longitude and latitude of the headquarters for that company. And we're going to quickly do some things that we did previously, just in a slightly different way. So I'm going to talk through a few things, and then we'll get right into the k-means clustering. So notice I read in this data set, and it comes from a CSV file. And the file path, you see that I have 2 backslashes. Something I didn't mention before is that R requires forward slashes. If you're using a window machine and you try and copy the file path, it will give you backslashes instead of forward slashes. So 2 ways to fix that is you can add an additional backslash, and then that will tell R that you're using the right thing, or you can switch them to forward slashes. The way we did it in the previous videos, we just used the output that that clicking through did to give us a file path. And if you look back to those were forward slashes. So a little quirk of R. Then I want to show you how to create a function, and we're going to use this function to clean some of the data out. And then we're also going to do something that we did in the previously, and that is to transform variables to kind of look more normal, or to sort of reduce the effects of outliers. So this, I'm creating a new function here, and this function, I'm naming it, and I'm using it to get rid of infinite values or missing values. And how we create a function is we assign an object, name it this, tell it it's a function, and the things that enter the function are in parentheses here. We're going to call it x, and so whatever we put here is going to be the x that is used later in the function. And then in the curly brackets is where we put the function that we're going to create. At the end, we have to have an output to the function, so here I'm just outputting the x, whatever we input, it's coming back out once we change it. This part here, we haven't worked with square brackets, but the square brackets say within the thing that we have, this is going to be some column. Within that column, what are we looking for? And within that column is going to be some conditions. This is going to give us the rows that meet those conditions. So here is infinite. So if it's infinite, it's going to take that row. The vertical bar means or, so or it is missing, so this is is.na, or there's a different type of missing that is is.nan. So if any of these occur, then we're going to do something here. So if x is infinite or missing, then we're going to set it equal to, so notice this assignment operator here, we're going to set it equal to the quantile, and we're using 0.5 of x, and calculate that removing missing values. So what this is going to do is say, if it's missing, set it equal to the median of x. And then it's going to return x. So what that will do is put in a bunch of medians back in here. Okay, so we're going to use this function in a little bit, but once you run it, notice it says now you have a function down here you can now work with. And we could create all kinds of functions as well. Okay, so first, this is what we had worked on previously. We're trying to transform and take care of extremes. So natural logs, this function that a little complicated function, but it uses positive and negative values and can create something sort of like a log. And we're taking care of missing values in R and RDA, and we are then ranking this. So ranking RDA and naming it this. So now we have all of these transformed values. Now we have problems that some of those are going to create missing values or problems. So taking a log of something that is negative will give, will reject that, right? Or if we put a 0 in here. Similarly, this, if it has some problems, will return either infinite or missing also. So then we're using this function here to do what was up here. If it's missing or anything like that, set it to the median. So for all of these variables we're going to use here, we're going to do the function. So create a new column using this function on the same column. So we're just writing over that column. So at the end, we should end up with ones that are not missing and they're set somewhere in the median value. Of course, there are other options where we could just delete those that have problems, or we could try and predict what those values should be. There are lots of options to that, but a simple way that we'll use here is just to set it equal to the median. So, for example, if we look in here at the data so far, and we look at, let's say, total sales, notice there, total assets, there are some zeros. Sales growth, there are some missing. ROA, there are some negative infinite and some positive infinite, which happen because we're dividing by zeros. So, problems throughout here. If we look in the longitude and latitude, somewhere in here, I think we have missing values, but, I'm not going to be able to find them right now. So we have a few problems that we want to take care of. Run this, it's going to remove those missing and infinite values, and it's going to transform these variables. So anytime we're doing any of these analyses, we always have to think about these problems, and especially when we're doing k-means clustering, because it requires mathematical calculations to come up with those clusters. So we need this to be sort of well-behaved data before we start to do the k-means clustering. And if we look in here, notice we have no infinite in total assets. We do have some sales growth that is not fixed, but that's because if we go over here, we created new ones. So these are the new variables. So notice nothing here that looks like a problem, nothing here that looks like a problem. So all of these new ones we created are the ones that we dealt with the missing and infinite values. All right? So we've got sort of cleaned up variables. And then the next step whenever you're doing a clustering analysis is these variables, if you need them all to be considered equally when you create the clusters, you need to get them on the same scale. So again, let's look back over here. Notice that asset growth, let's just look at the extremes. So asset growth here, -6, and log of total assets, about 8, right? So those look okay, but the R&D rank goes from 1 to 30,000. So if we include just the rank in here, this 30,000 is going to dominate everything else here because the distance measure is a calculation for how different one row is from the every other row. So if we're trying to look at how different RDA, this RRDA column is, so if it's calculating this 30,000 minus something down here that's a 1, then that distance measure is going to be really large compared to these other ones that aren't so different. So we need to get them on the same scale. So we'll just do one that is typical here, and I'm going to do that with a new function. I'm going to call it norm for normalize. Again, it's x that is what's going into it, so whatever we put in here, so notice norm is the function we're going to use down here, and we put in a column there, so then x is the natural log of total assets. And in this one, we're going to say take x, and I need to output something, take x as a, and create it from x minus the minimum value of x divided by the range of x, so the minimum minus the maximum, and then output that x back into the same column. So we're going to do this with all of these variables that we're going to consider for looking at or creating the clustering. A couple of things to think about here is now we have the normalized value of the longitude and the latitude. So then those aren't going to actually be longitudes and latitudes that we can interpret. So we have to get back to something that we can interpret later if we're going to use it. The same thing with these other variables. They're not very usable in terms of things we can go back to say, something about the raw data. But now if we run this, we have a new function over here, norm. Run this, dataset 2, and let's look at those new columns we have. Notice our RDA goes from 0 to 1. Let's choose another one, log of total assets goes from 0 to 1. So all of these variables now are on the range from 0 to 1. So we can now use those in clustering because they will be used sort of equally among those variables. Of course, there may be circumstances where you don't want that, but in this case, this is what, we're going to just try and give them all the same amount of importance. Okay, so we're going to do the actual clustering now. We need to select the variables we're going to use, so I'm just going to select the ones that we've been messing with and creating and preparing for this. They're all normalized at this point. So I'm going to create a new data frame, clus data, that I'm going to use for the k-means clustering. The actual mechanics of doing k-means clustering is pretty easy. It's a k-means function, input the data frame that we're going to use, and then these two pieces are things that we have to change and decide what we're doing here. So centers tells how many clusters we're going to end up with. So this is a sort of machine learning method that we have to fine tune this, right? We have to decide how many centers need to be in the data. So you just have to work with this until you find one that gives you something sensible. I'm going to choose 5 for now, but if you're doing this and you're going to use the analyses or use the clusters, in the end you probably would try different numbers, 3, 5, 10, whatever. The number of clusters that we're starting in, it randomly assigns all the rows into that number of clusters. So randomly assigns into 25 groups, and then it works through until it gets down to 5 groups by taking one observation from one cluster, moving it to another cluster, and it keeps doing this until it finds 5 groups where within the group they're similar, but they're different from the other groups. So again, that's something you can fine tune and mess around with. To me, what I've seen that matter the most are what you put into the clustering algorithm and the number of centers you use out. The starting point does matter a little bit, but doesn't seem to have such a big effect, at least a lot of the time from what I've done. Okay, so we create this data we're going to use for clustering. Just to be sure that this is what came out of it, notice we have this over here, and it's only the variables that we're going to cluster with. So we're going to decide how different an observation, this row, for example, how different is row 1 from row 5, and it's going to keep looking through these until it finds groups that fit together. And it's going to do it based on these columns that are in there. So how different is row 1 from row 5? in terms of total assets, sales growth, ROA, ROE, all of these things. Okay, so we run the cluster. We run the k-means clustering. I'm using 5 centers, starting with 25, and what comes out of that will be the clustering output. So the warning is it couldn't do the quick version. It has a couple different versions. That's okay. We can continue on with that. We could adjust some things, but not a huge deal. And later on, we'll change things where that won't happen. So doesn't really make a big difference. Okay, so then we look here. We could look in here, but it's a bunch of things that we're not going to really understand, but it gives us something to work with. So this within this and total, this is and between is trying to tell us how well it's fitting. But the things that we are going to really care about are the size. So this is the size of each of those 5 centers that we chose. So if we run this, notice it has made 5 groups, 1, 2, 3, 4, 5, that have different sizes. So the first group is 1,000, the second group is 5,000, third group 9,000, fourth group 2,000, and then there are lots in the last group. So sometimes we would like those groups to be more similar in size, but this tells us there is something that there is a group that there are lots of rows that fit in that group. So we could mess around with that by changing which columns we use, how many centers we use. There are a number of things we could try. But this gives us an output of that. And then if we want to describe sort of what those groups look like, we can use the centers. And what that does is say the typical observation in each group according to the input variables that we use. So these variables here. So if we run this, now what it's doing is saying the typical observation in group 1 is, has this value of total assets, this value of sales growth, things like that. Let's see if we can figure out, so the last group, the one that was the largest, is this group here that had 12,000 observations. Let's see if there's anything about that group that makes sense. So notice it is the largest in size, so look at these other ones. And because this is a standardized variable, it's sort of like above median is above 0.5, below median is below 0.5. So we have in this last group, the one that is the largest, have the largest in terms of total assets. Notice in terms of sales growth, no difference in terms of those, almost no difference in terms of ROA or ROE. Or profit margin, maybe a little bit. These are the most profitable in terms of profit margin. Something we see very different here, though, is this is a no R&D. This is the lowest R&D group. So these other two here are high R&D. This is low R&D, or zero R&D, and same thing with these two here. So we have a group of that doesn't have any R&D, that is the largest in terms of total assets, and the location, maybe that matters some, right? So look at longitude. We have 2 that sort of have larger longitude. So, we've got on the map, we would go farther to the right in terms of the longitude, and the biggest ones are farther down in terms of latitude versus these other ones. So we could try and pinpoint on the map where those are, but there is some location aspect to this. Same thing with the latitude, right? So these last 3 groups seem to share basically the same latitude, but they have different longitudes. So we have an R&D, no R&D, large company, specific location group cluster. Then we have 2 other no R&D clusters that are smaller in size and This one is sort of in the same place as this last one. This first one seems to be in a different place, right? The longitude's quite a bit different from the large company longitude, and the latitude's quite a bit different from the large company latitude. So we've got, let's try and summarize this. So of the R&D, no R&D groups, there are large companies here at this latitude. Then there are smaller companies at two different locations, one that is near the same location as the large companies, and then another group that is at some other different location. In terms of those that actually have R&D, let's see if we can see anything about those. Size, the second, group 4 is a little bit bigger than group 3. Nothing else is very different here, but it's really location again, right? So latitudes are basically the same, but this group has a much smaller on the longitude than this group. We could then, and this actually is closer. So this group here is closer to the large group and the small R&D group. Then there's this other one that is closer to this other set that is not R&D. So we've sort of got two primary locations that are determining the data, and we have R&D groups and non-R&D groups at these different locations. So you're sort of getting this idea of what's happening here. When we do these clusters, we don't know ahead of time what the clusters are going to look like, and there's no ordering that makes sense. It's not like one is, has certain attributes, and as you move from 1 to 5, then they increase in those attributes. The only thing we can do is go back and look at what those clusters look like, and then try and interpret what those mean. If we have longitudes and latitudes, that's a little bit easier. If we go, if we start doing other things that may not have an easy interpretation, then it gets even harder to figure out. Although mathematically these clusters exist, we don't know if there's something we can interpret. But if we keep digging in here, right, maybe I could change the clusters, maybe I could change what variables go in there, then I can start to figure out understand the data a little bit more, and hopefully as you go down this path, you start to be able to figure out what's important in the data. All right, so we have these different clusters, gives us a little bit of idea of what these types of groups are. I would say R&D and location are primary here in the data. There's a little bit in terms of assets as well. And if we wanted to figure out more, maybe we could, sort of nail down each of those things. Then at the end, let's say we are satisfied with these clusters that we've created, and we want to then go use them, either to explain what's going on with those rows, or to predict something, or or do our analysis by cluster. There are a few things that we might look at doing. So how we could do that then is this cluster that is in this output tells for each row which cluster they fit into. Well, I can just put that back into the data set that I was using. So if I put it into this data set 2, I'm going to call it the CL groups, and I'm going to get it from this cluster that is in this output. We haven't done this sort of formatting before, so let me just talk for a second about this. In this case, this data set 2 is a data frame. The $sign says go within the object that we have here. So in this object, go to the column that is CL groups. Well, we're going to create that column by doing this assignment here. So within dataset 2, go to create a CL groups column. This one says within this object, so this is the cluster out thing. Well, it's a list. So within that list, go to the item cluster. So if we go down here, this is the $sign cluster. That says, okay, within this list, go to the cluster item. So that's how we use these, how you can travel between an object down to a lower level object. There are other ways too that we'll get to maybe at some point, but essentially most of what we're going to be doing is say this data frame column. So this is, you could think about this similarly within this data frame, this column, even though this is a list. So once we do this, now we can create a new column in the data set 2. So if I go over here, go to the end, notice it has a new column, CL groups, and it says this row is in the group 3, this row is in group 5, and similarly as we go down. All right, so this is the mechanics of trying to work with clustering and also trying to interpret it. Where the rubber meets the road is trying to figure out what these mean and how to use them, and what to put into them. And we'll do a little more of that in class, but getting to where you can actually run it is a great start.